I'm a pretty big nerd when it comes to playing board games with my friends and family. And if you've played a bunch of games like I have, then you know that lots of them can have a ton of little pieces that you've got to manage. And that's why I made these things. They're little hexagonal trays that you can click together magnetically to configure out exactly what you'll need to keep all the game pieces organized. These things have proven to be super helpful, convenient, and fun to use, but they haven't helped me improve at the games I play. I'm still a pretty big loser most of the time. Well, in this video, I'm going to show you exactly how I made them and then show you where you can find the CNC files to make some for yourself. So let's get into it. The first thing that I needed to do was to head over to my neighbor's house and steal some cool looking boards to carve all these little hexes out of. I picked up some ambrosia maple, some curly maple, and some ash. And then I searched my own stash and I found some cherry and some rosewood and of course some black walnut. Next, I trimmed down each of the boards to about 2 feet in length. After that, I could pull out the planer and run each of the boards through it to get them down to their final thickness. Eventually, I got everything down to exactly 3/4 of an inch thick, even this piece of divine rosewood. You can tell it's divine rosewood because it's holy. I designed all the hexagons on the computer, and I oriented them so that I could cut out 5 of them at a time. I exported the G-code onto a thumb drive, and then I headed back down to the shop and back into my robot room. This is my CNC. I have the Pro Series Woodworker X50 from Onefinity. I've had this machine for years now, and it's been absolutely amazing. This is actually one of their earliest models, and now they have machines available that are vastly superior to this one. Be that as it may, this one is just the right size for me and my tiny shop. Now, since I'll be doing cut-through operations, I'd like to glue down a thin piece of plywood onto the bed. I just use the old painter's tape and CA glue trick to temporarily fasten it down onto the surface. And this will keep me from marking up and damaging the CNC table when the bits cut all the way through my project material. Then, using some lever-activated clamps, I can slide them into the T-track and clamp down my workpiece. Now, I like to use little scrap pieces of wood too, because it takes up less space on the workpiece and it keeps my clamps further away from the CNC router. So these are the 3 bits I'm going to be using. They are all from the Jenny line of bits from Cadence Manufacturing and Design. This is the Mini Jenny. It's an 1/8 inch compression bit. This is the original Jenny bit, 1/4 inch compression. And then this one is one of his newest ones. This is called the Bowl Cut Jenny. And what's super nice about this one is not only is it a 1/2 inch round-nosed tip bit, but it also has a flat tip. So you can still do like a 20-25% step over and still have just a flawlessly smooth bottom at the base of your cut. So really excited to show you guys how these bits perform, and if you'd like to check them out yourself, head on over to his website and use the promo code Fisher10 to save a little bit of money. So for my first cut, I'll start with a Jenny bowl cut bit. It has a 1/4 inch shank, so I put in the right collet and I get it tightened down into place before putting my Z-probe block onto the workpiece and setting my zeroed height. At this point, I can plug in my USB drive that has all my viruses on it and load up the right file and hook up my dust collection shroud and kick off the job. This first cut is just making all the round pockets that'll be in the centers of the individual hexes. The round nose of the bowl cut bit will make it super easy to get whatever's on the inside too, since it can just ride right up the edge. Once that part's done, I can switch out the bits for the 1/4 inch compression bit, and I can use that one to cut all the outlines of each piece. And since I'm changing bits, this means that I need to re-zero my height. The cut worked, but it was quite nerve-wracking because of something that just didn't occur to me. Okay, well, it worked, but the clamps are getting in the way. I had to really quickly add these 2 things in there because I realized once I cut through on each of these, this is completely separated once it comes out the top here. And at the bottom, there's like not even an eighth of an inch left of material holding this together. It's more like a 16th. So it was getting flimsy because originally the only places it was held down was on the ends. That one there and this one over here. So I'm going to have to find a different solution to hold this down. I think I'm just going to use the double-sided tape to stick it down. Then I won't have to use any clamps, and I can run this without any hiccups at all. So I'm going to try that. So I did exactly that for my next attempt, and since I wasn't using any clamps, I had enough room to put on my dust collection shroud. Furthermore, it never got flimsy, and it remained very stable for the entire cut. It worked perfectly. And all the dust got vacuumed up, and everything stayed clean. This is definitely the way to do it. One thing I did notice, though, was that sometimes some of the machine tool marks could be seen inside of the pockets. And in some cases, it left a little burn line that needed to be sanded off. And since sanding that by hand would be a nightmare, I picked up this little spongy sanding adapter thing. You simply put on whatever grit you need and then chuck it up into your drill. This made short work of removing the tool marks and the burns from these pieces. The next step was to zip through the tabs, and then using the belt sander to smooth out the sides. Using the small 1/8 Jenny bit, I cut out another design which can be used to hold playing cards. All in all, I made 4 different designs of tiles that one can use, which should allow them to pick and choose which ones they'd need for whatever game it is that they're playing. But now that we have a stack of these hexagonal trays, I needed to come up with a handy way to store them when they're not being used. I went to Fusion 360 and I designed this little cradle. From there, I was able to take the shape of the end caps, replicate it, and lay it out so that I can cut out several at a time. Now these shapes have 2 mortises in them for the crosspiece. And you'll notice that I had to cut in little relief holes in the corners. These are called dog bones, since you can't cut a perfect 90-degree corner with a round router bit. But these will get hidden by the shoulder of the crosspiece tenon after assembly, so you'll never even see them in the end. Afterwards, I took each one to the spindle sander and I got rid of the tabs and any tool marks that were on the sides. Now, to cut the tenons of the crosspieces, I needed a way where I could secure each one into the exact same position every time. I figured an easy way to do this would be to make a jig that each one could fit inside of. That way, I'd only have to zero the machine once and it would always be the same. I cut in the shape of a crosspiece as well as some finger holes into a piece of 3/4 inch plywood. Then I glued it down onto a slightly larger one so that I could easily have enough room to clamp it down onto the bed of the CNC. Once I had it secured down to the bed of the machine and I made sure that it was square to the router, I could put in my first crosspiece. Zero the machine to it, and try it out. In my head, this seemed like a good idea, but my head also thought that eating 3 pounds of shrimp in one sitting was a good idea too, so I wasn't surprised when this happened. Well, that didn't work. I'm going to need some kind of clamp to hold this thing down because the vibrations made it climb right out of the jig and the bit just sort of went crazy on it. So that's not good. This time, I shaped the end of a stick so that when it was clamped down, it was putting downward force right in the center of the crosspiece that's in the jig. And everything stayed perfectly in place, and the machine was able to cut in the dado that goes down the length of the piece, as well as the first half of the tenons on either side. Then, when the cut was finished, I could take the piece out, vacuum out any dust that was inside the jig, flip it over, and run the program to cut in the other half of the tenons on each end. A quick test fit, and perfect. Now I could take all the pieces over to the router table where I could add a small 1/8 inch roundover to all the edges. And just in case you couldn't tell, this footage is sped up just a bit. Next was the most brutal part of the project, and that was sanding all these pieces. I found the easiest way to do this was to clamp my sander upside down onto my bench. This sped up things dramatically and it kept my hands from cramping up. Now, to make the hexes click together, I thought magnets would be a good idea, but I had to make sure that they'd be perfectly centered and equidistant on all the sides. And to make that happen, I just put together a real simple jig for the drill press that was basically just a fence and a stop block. Then, after drilling each hole, I just rotated the piece to the next side. Once all 6 sides were done, I could then just flip the hex so that it was facing the other direction, and then drill the remaining 6 holes, and they would be a perfect match to the others. I was really hoping that this would work, because it was a long road just to find something that would hold them together as well as I wanted. Well, the hardest thing about this whole project was finding the right magnets and hardware to use for this whole thing to work that would allow me to hold 2 hexes together in any orientation. So what I ended up doing was I tried multiple different screws and multiple different kinds of magnets and steel plates for the cradle so they could be magnetized in the cradle as well, and lots of failure upon failure. But finally I discovered a design that would work, and what we're going to end up doing is using these tiny little guys. These are neodymium magnets, just tiny little magnets, but they're super powerful, and we're going to drill undersized holes into the sides of the hexes, and then we're going to press fit them in there with opposite polarities. That way the opposites will attract and they'll be able to click together, and it won't matter what sides you put together, they'll always be opposite and click in. So to tap the magnets into the holes, I used a large nail set and I stuck the magnet to the end. Then, using my patent-pending earmuff clamps, I could check, double-check, and triple-check the polarity of the magnets and then tap them into their holes. And if I screwed this up, there was no getting that magnet back out. The hex would just be ruined, and I'd have to go and make a new one. And after setting 12 magnets into each hex, I then checked it against another one to make sure that each side clicks together to another one as it should. Then, to try to speed up the process, I would lay out a bunch of magnets at once with all the same polarity facing up. This cut down on the time it took quite a bit, but man, it was still a chore to complete them all. In total, it was 540 magnets that I had to tap in. And surprisingly enough, I managed to get them all in place without a single "oh crap" being said. I know, crazy, right? But just check out the holding power of these little guys. That's pretty amazing if you ask me. Now for the cross pieces. I found these bar magnets to be perfect. They came with some double-sided foam sticky stuff too that I used to hold them down into the dados. But again, I had to make sure that I had the polarity going the right way so that they'd be able to hold the hexes in place. Next up was assembly, and it really couldn't have been easier. I just spread a little glue into the mortises, making sure that a thin layer was on all 4 walls of it, and then I just pushed the tenon of the crosspiece into place. I repeated the same process for the other side, and then added a couple of squeeze clamps to close up any gaps. Then once they all had enough time to completely dry, I could remove the clamps. So for a finish, I'm going to be using this. This is Willie's Wood Honey. My buddy Will Corson stood up his very own wood finishing business, and this is his very first product he's releasing. It's called Willie's Wood Honey. It is a tung oil based hard wax oil finish. It's super easy to apply, and I've used this on a number of projects already, and I really like it. It's super easy to apply. You just wipe it on, kind of buff it in with a white Scotch-Brite pad, wait 30 minutes, and then wipe it off. And that's it. You can immediately handle the project, and then over time it hardens as it cures, and it offers a lot of protection to the piece, as well as it really brings out that natural color and luster of the wood itself. So that's what I'm going to use. If you guys want to try it out for yourself, head over to willieswoodfinishes.com and use the coupon code FISHER10. That'll save you a little bit of money. I really do like this finish, and like I said before, it's super easy to apply. I just smeared it around the surfaces with my fingers, making sure to get it down into all the nooks and the crannies, and then I followed that up with a white Scotch-Brite pad to work it down into the wood. And for the pieces that had hard-to-reach spots, I just used a brush to make sure I got some finish all the way down into those areas. Then about 30 minutes later, I wiped off any excess from all the pieces and I was done. And again, check out the holding power of these little magnets. That's just so awesome. Well, here they are, 5 complete sets of some game organization hexes. They just look so neat, all stacked up in their cradles with their shiny little magnets. And all the different species of wood really adds a lot of character to it too. But I just can't get enough of clicking them all together. It's just so satisfying. So I ended up making some with big round pockets, a few that look like flathead screws, some to hold cards, and one with a big slot in it. You might be wondering what that's for. Well, that's for holding your phone. This will hold your phone at just the right angle so that you can record the faces of your opponents as you destroy them at whatever game you're playing. These little things have proven to be super useful. Each player can take a few, click them together, and keep all their pieces organized. And since you can mix and match them, they'll work for pretty much any game that has pieces that you have to manage. And even if you're not a gamer, you could use them for candy dishes, coasters, or even like a customizable charcuterie board. And when you're done, they all just click right back into the cradle for easy storage. I haven't really done a project like this that was almost 100% cut on the CNC. It was pretty fun, and yet challenging to figure out that whole side of it. And since I have all that figured out already, I decided to bundle up all the files and write up some instructions so that you could make the same exact thing on your CNC. If you wanted to try it for yourself, head over to fishersshoponline.com and pick up the files. It's just $5. Hey, thanks to Onefinity for making such an amazing machine, to Cadence Manufacturing for designing some incredible bits, and to Will Corson for coming out with his incredible wood finish. None of these guys are sponsoring this video. I just genuinely really like their products, and I encourage you all to check them out for yourself. Well, I hope you liked the video, and that you would consider giving it a like, a comment, and even subscribing to the channel if you're new. Well, thanks so much for watching. That's it for this time. Take care, and I'll see you later. Oh, crap. Oh, I was gonna do the... Oh, crap. Shoot. Forgot to do the thing. Oh, forgot one. Crap. Well, from the other room, I heard that this machine was not sounding right, so I came running in here and I had to hit the big red oh crap button to stop it. Looks like after it was done with this one, the bit had slipped down and I didn't have the collet tight enough, evidently. So it actually plunged all the way through the board when doing this one, and then when it went to move to do this one, it just dragged the bit right through it, doing a massive cut. So this part of the board is trashed, but I can hopefully still get a good one here and there, so we'll try it out.